All right, so now the equations get a little more complex, but we can still get through them, okay? So once again, we're not worried about the computation. We've got calculators. What we're looking for is drawing back on what we learned in the past. So a little bit of our prior knowledge and the patterns that we've been seeing as we're going through to see if we can go ahead and find a correct solution to this. All right, once again, I'll be using equation letters as we go through this. So here's the equation, the original. 4 times the quantity of x plus 2 plus 18 divided by 6 equals 2 times the quantity of x minus 6 minus 1. All right, so let's go ahead and take a look here. So the first thing I want to do here is not attack the fraction. I want to go and simplify all the this expression up here. So that's going to be, oh wait, let me get my writing tool. Okay, so that's going to be combine like terms, and that will be letter B. So I got a letter B here, and notice, once again, combining some numbers. And I make sure to put the signs in there as well so I know it's 8 positives, it's 18 positives, okay? And then notice as well, on the right-hand side of the equal sign, or the equation, how you want to see that, I have some like terms as well. The integers, -1 and -12. So if I were to combine those, I would get positive 26. And if I combine those, I would get -13. All right, so we're done with letter B. Let's move on here. So I have unlike terms here, so I can't combine. I can't combine here. So then over here, I don't have like terms, so I can't combine there as well. So what I want to do now is go ahead and cancel out the denominator here by applying the LCM. Luckily, there's only one fraction, this fraction here. That's a fraction, Mr. Eve? Yes, that's a fraction. Okay, if you really wanted to, you could see this right here, just multiplying this way. 6 over 1 times 1 over 6. Wait a second, Mr. Eve, how did you get 6 over 1? Because I can change any whole number into a fraction using that. And how does that make sense? Notice. 6, and I put 6 over 1. How many sets of 1 are in 6? 6. I turn that 6 into a fraction. How many sets of 1 are in 6? 6. I think you get the idea. So I can do that. And I'm going to take that 6 that's underneath here and snatch it, because I could have, technically, not saying, you should do this, but I could have 4x plus 26 over what? Over 1. Because notice, if I multiply 6 times 1 and I multiply, don't worry about that over there, that, I get what we have here. I hope that makes sense. Let me put a little check. So notice 6 times 1, 6. 1 times 4x plus 26 gets the same thing. So you can see it that way if it, throws you off. But once we do that, cross cancel, and we have, that's going to be 1 and 1. And we know that 1 times 1 is 1. And we know we do a wind up, how many sets of 1 is in 1 is 1. And so in a sense, that's why this cancels out. So 6 here cancels out that. Now, once I've done that, I'm going to go ahead and take my 4x plus 26 and snatch it and bring it down here. Don't worry about what you're seeing right there for now, because we got to shift gears. I did go ahead and do an LCM, and that was letter D. I'm going to put it right there. And then, but notice I also had to do a letter C, because I had to apply the distributive property here as well. So let's do that, okay? Let's apply the distributive property. I'm going to go to this side since it's kind of jammed up. So I'll apply distributive property here. 6 out of 2, 12. Drag the x along. Notice I'm multiplying here. Anytime I multiply, divide, or find the quotient or product, what I'm doing here is that I want to count the amount of negative signs. So there's 1 there. Anytime it's an odd amount of negative signs I'm counting, the resulting product in this situation is going to be negative. 6 sets of 13 gives me 78. All right, so negative 78 when I apply my distributive property. Done and done. So I'll go down here, take this expression 4x plus 26, the products of that, 12x minus 78. It looks like I made a choice to keep the variable on this side and the numbers, integers, constant on the other side. So on the left hand side. So let's go over here. if I want variables, looks like I need to go ahead and take care of this side. Let's get the variable over there. So I have the variable 4x on this side. Let's go ahead and get rid of that. So if I have 4 positives, I have 4 negatives. You already know from the number line exercise I did with the other challenges. So we go over here, that's going to leave me at 0. What I do on one side, I do to the other. So I had 4 negatives over there, drag them over here. And if I do arithmetic, 12 minus 4 is 8. If I use algebraic thinking, 12 positives, 4 negatives, 8 positives. So now we're done there. Didn't do anything to the negative 78. We just bring that on down. So now remember that we're at variables on this side and numbers on this side. Let's continue on. So remember, I had that negative 78, but it's on the variable side. I want that to get over to the number side. So let's go ahead and clear out the variable side of any numbers. I have 78 negatives. I need 78 positives. Or if you're doing arithmetic thinking, 78 minus 78 gives us nothing. What I want to do here is what I did on one side, I want to do another side of equal sign. So I have 78 positives there, 78 positives over here. Using arithmetic, it'd be 26 plus 78 gives me 104. Algebraic thinking, 78 positives, 26 positives, 108 positives. Excuse me, 104 positives. And last but not, I did a lot of work here without letters. So let's see what I did here without letters. I did an A. I did the inverse operation, this time involving variables. And then I went here, did an A, this time involving integers, constants. I want to see numbers. So now I'm down to letter what? Letter E, F, B, baby. So let's do a fraction bar. So fraction bar, I divide by the coefficient of the variable. The coefficient here is the letter, is the number 8. So I call it eyeball check. Whatever you see, you divide by. So do a little quick wind up. Invisible uno or 1, because how many sets are 8 or an 8? 1. Let's go and push this back down. Sorry about that, guys. All right, go back down. One more. Okay. And so then you'll have 1 in that situation. Now, how many sets of 8 are in 104? 13. So I trust that my answer is right, but let's make sure I verify that it is. Okay, so trust that x equals 13. Let's verify. So I take the original equation here, and the value of 13 is where I put, or anywhere there's an x. So there was 4 times the quantity of x plus 2. Where that x is, I put 13. Over here, I had 2 times the quantity of x minus 6. Where that x is, notice I put 13. Plug them in, do all the operations they asked me to do, and notice when it's all said and done, the number on the right-hand side is the same as the number on the left-hand side, the equal sign. And what do we know that means? That means that we have verified that 13 truly is the solution to this given equation. There's no other solution. It's only one. You couldn't put 13.1. You can put 12.99. It would not give you the same answer. So that's the solution, and that's it.